Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in PHYSICSSIRJEE Resolved series, in which we bring forward problems or concepts that usually trouble toppers themselves, and the doubts that are asked by toppers which are usually not clarified either in the internet or in the standard textbooks at one place are brought forward in this very beloved series, and all the old subscribers would vouch for this Resolved series. Okay, so I have brought forward a question which is from Kvpy 2018 SX, that is the second year or the 12th class paper. A very nice question on the Heisenberg uncertainty principle being used to calculate or estimate the order of the energy of each of these four situations that are on screen right now. During this problem, we'll try to understand in a brief what is meant by uncertainty. Is it an error in an experimental measurement, or is it a part of the reality? And also we'll try to relate uncertainty in momentum with average value of momentum and average value of kinetic energy. So these are the symbols I'll be using for average, and the delta as usual is the one used for uncertainty. So this is going to be a very joyous and concept filled ride. So I hope you are all ready for it. Okay, as the case with most of the resolved problems, at the end of the video, I'll give you a practice problem on a mixture of concepts from modern physics infused with uncertainty. So I hope you'll stay till the end of the video to grab that practice problem. Okay, so let's move forward. This is the problem statement from that 2018 paper. So in case you want to unbiasedly attempt this particular question, pause the video here, try to attempt it for 4 to 5 minutes, and do come back for the concept, solution, and also the practice problem at the end of the video. Okay, so I'm going ahead with the formal reading. Using the uncertainty principle of Heisenberg, arrange the following particles in the order of increasing lowest energy possible. Okay, an electron in hydrogen molecule. The second state is a hydrogen atom in hydrogen molecule, a proton inside a carbon nucleus, and a hydrogen molecule within a nanotube of gas of hydrogen. Okay, so these four situations you're supposed to write the order of the energy. So most of the times this energy will be associated in these situations with the kinetic energy of the situation. Okay, so that has not been mentioned, but that is a trivial thing that you need to understand in this problem. Okay, so let's move on with the concept. So just before we do that, a humble request, as I always do, to ensure that the channel reach increases, please do like this video. So the kind of concept that we are going to deal with in this video would not be found at one place in one book or in one video. So it's an amalgamation of a lot of things that have been done or studied by me and then brought forward for your convenience. So I hope this deserves a like so that I get that support. Okay, so thanks for all those who are unconditionally supporting and liking all my previous videos. So that does a lot of good for the channel. Okay, so let's move forward. So a brief concept of uncertainty, you should understand that whenever a matter wave is considered, like an electron which is traveling at a certain speed, in modern physics, especially in NCERT, we do consider it as a wave packet. Okay, so now this electron is not a localized one. We cannot say electron is here. Electron is actually spread over a certain region called delta X, as you could see on the screen. Now the idea is, if electron has only one de Broglie wavelength, okay, so if this was the electrons depiction, then it was spread throughout all of the space, right? Because a sine curve with one single wavelength or frequency would have spread from minus infinity to plus infinity. So in this single lambda, that means delta lambda is 0, the value of delta X would have been infinity. So in general, the electron which is moving is not considered to be having one wavelength, right, but a combination of many wavelengths. Actually, this is a very easy depiction of 1, 2, 3, 4, 5, but it's uncountable. It's a spread of wavelengths. As you mix more and more wavelengths to form a wave packet, the value of delta X reduces. And that is what has been written here. You can pause and read it on your own. So you should understand, when someone says there is a delta lambda or a delta X for a particular wave packet, like an electron moving or a proton moving, that uncertainty is not an error in measurement. It is actually a reality. So an electron has more than one wavelength, centralized wavelength, and a spread of it. So it's a reality that you need to accept. Okay, so that is something that is depicted in a slightly better manner in the next slide. You could see, therefore, as I said in the previous slide, If the electron was represented with only one wavelength, that is one sine curve, as you all know, if you draw a sine curve, it goes from minus infinity domain to plus infinity domain. That means the value of delta x tends to infinity when delta p or delta lambda tends to 0. Okay, right, there is no spread. But once you add more and more wavelengths and claim that the electron is a mixture of wavelengths, that means there is a delta lambda which is finite, then the value of that spread, right, you could see that the electron can be now located within a smaller delta x. So as you increase the value of delta p or delta lambda, the value of delta x reduces. Okay, so large delta p, you will have this. With rigorous statistical and quantum mechanical conditions and calculations, you end up getting this expression for the Heisenberg uncertainty principle that we have in our NCERT textbook. Okay, so uncertainty in position multiplied by uncertainty in momentum should be always greater than or equal to the value of Planck constant by 4 pi is something that is derived from the quantum mechanical calculations and wave functions of Schrodinger and etc. Okay, so we take this expression for granted because we don't prove it in our 12th class syllabus and move forward in the question. Okay, so one very important thing that we need to understand before we move on to the question is how is uncertainty related to average value. As I said, this is a statistical condition, right? Uncertainty in position square is equal to average of the square of the position minus square of the average. Okay, so this is something that is also learned by students in statistics relating the value of mean and standard deviation. So same thing if written for momentum, the square of uncertainty is equal to the average of the square minus the value of the square of the average. So this is something we learn. Now, if we apply these two conditions to a special case of the four problems that has been told in the original statement, right? There were four conditions: electron in hydrogen molecule, electron in hydrogen atom in hydrogen molecule, etc. In all of this, you should realize that electron has equal chance to move in multiple directions. So the value of average momentum, which is a vector, is considered to be 0. Okay, because of 3D symmetry or a 2D symmetry or 1D symmetry, these kind of situations are considered as a particle in a box type. So in that, the average momentum vector comes out to be 0. Same happens in even the ideal gas situation where average momentum vector is a 0. So if you substitute this average momentum vector here as 0, you realize one thing very, very interesting, but directly taken in calculations in most textbooks without explanation. That is, the uncertainty square is related to the average of the momentum square. Okay, so that is something we are going to take in each of these four situations. Remember, if an electron is freely moving, you can't do this. Then you have to consider this one. Once it is in a box and all the directions are symmetric, then this condition happens. I'll show you one example before we move on to the problem to realize how that is directly taken in textbooks. Okay, so this is one standard textbook, and in a solved example is there in which uncertainty is used to calculate or estimate the average value of kinetic energy. Okay, so you could see we write this expression and we say a hydrogen atom has this much radius, and electron in the atom has average momentum is 0, right? And you're supposed to use uncertainty principle to estimate its minimum energy. Okay, whether it matches with the Bohr's model or not is not the issue. He's requesting us to use uncertainty principle to judge the value of the average kinetic energy. Okay, so let's try this one out. The value of delta x is equal to 5.3 into 10 power minus 11. Okay, so because that is the radius, you would say on an average, the value of the uncertainty where the electron could be anywhere within this is of this much order. All these are orders. You might say diameter should be taken and all this is just an estimate. Okay, now, and then use the uncertainty principle and get the value of delta p. And you could see without any explanation in the book, he's using the value of delta p that is obtained here in the average value of p square. And this conversion is allowed because of this relation that I explained as a doubt. All right, this is one of the doubts that most of my topper students ask, and this is the way to resolve it. I hope you now understand. And the value of kinetic energy comes out to be this, which is 3.4, but actual kinetic energy in the lowest level is 13.6. So it's not matching, but the order is very close. So that's why we say Bohr's model actually violates uncertainty principle. Okay, there are many other reasons why it violates. That is for another video in this particular channel. but this is how we use the value of average momentum 0 to relate to these two. Okay, right? A method which is often visited in Kvpy and Olympiads, and maybe a future comprehension style question in JEE Advanced. Okay, so with all this super knowledge, let's now attempt the question. Okay, these are the 4 conditions given, lot of things on the board. I'll explain one by one. Don't read it on your own. It will be easier if you follow my voice. Okay, so let's finally arrange them in the order of the energies or kinetic energies, because these are all particle in a box symmetric situations. Average momentum is 0, so I have this statistical relation, and I have the Heisenberg uncertainty principle here. Okay, so the value of delta x is inversely related to the value of the delta p, which is uncertainty. So lesser the value of delta x, higher the value of delta p, which in turn is the higher value of p square average. And we all know the k's average is the value of average of p square by 2m. So out of these, which one has the least or highest delta x goes to the extreme cases of that option. Okay, and you'd say carbon nucleus has diameters related to femtometer, which is a Fermi or 10 power minus 15. Among these 4, the smallest size is for the carbon nucleus. So the least delta x is for the third option, and therefore the highest energy will be for that. Okay, so we'll search for such an option. And the highest size is for a nanotube. Hydrogen molecule is smaller size than the nanotube. Please understand that. So the fourth one, which is the hydrogen molecule in a nanotube, has the highest delta x and therefore has the lowest energy. So these are the 2 extreme options. Now the catch is between 1 and 2, the delta x is the same. Can you see? The hydrogen molecule is the same. So we carefully observe that the average value of p square is same for both first option and second option, but there is a divided by 2m. So electron is lighter and therefore has the greater value of the energy. So one has a higher Ke than the 2. So among the 4 options, this is the correct order in the kinetic energy, which is the option B, as far as I remember in the original question. Okay, so I hope you got to understand how this solution is written in either textbooks or some solutions on the internet don't worry about this conversion. They directly use the delta p and p square as it is. They are equal, but they're not always equal. They become equal in this particular special case due to average momentum being equal to 0. So this golden relation that we have in statistics here also is used later on in the drift velocity calculation of electrons moving in a resistor, and from there we end up getting the resistivity relation, which we'll discuss in one other resolved video. Okay, so that is the crux of this particular concept. Okay, so let's move on to the practice problem now. Before I do, I'm available at different places for the students to connect to me. Okay, most important ones are the Discord server, where a lot of doubts along with the Telegram group, doubts of the students are resolved. I chip in only once a week or twice a week. It's mostly the topper students who are part of the group resolve their doubts from one another, and that is a nice building community of serious aspirants. Okay, also my website, which is PHYSICSSIRJEE.in, contains a lot of playlists and chapter-wise videos taken from the YouTube channel, and these chapter-wise arrangements will ensure students who are new to this channel to revise the concepts much faster. You can pick modern physics, you can pick kinematics, all these things at one go, and maybe in 1 or 2 days you finish all the videos on that particular topic from the website itself. So here's the website. Okay, so this is the landing page of the website, and how the website should be used and all. I have already made a video. The link of that is in the description below about the website, or in the I button above. You can check it out. Okay, so this is the practice problem. So it's slightly lengthier, like is the case with most of the modern physics problems on comprehensions. Comprehensions is one of the hot models that you will end up having generally taking place in the JEE Advanced. So these type of model of questions are comprehensive style, where the syllabus would be slightly outside the boundary, but all the information required for solving the problem is given in the paragraph. So you have to carefully read this. There's second page also, so you need to pause and read this on the exchange force and the uncertainty principle, followed by 2 questions. Okay, so this is the end of the passage, and these are the 2 questions. You can write the response after reading the question, comment the response below along with the timestamp. Timestamp is important so that I can check. Once the video becomes older and older, I will not remember what this is and all. So timestamp will help me in the comment section to directly go and respond whether your answer is correct. And in case most students struggle, I'll answer this in the PHYSICSSIRJEE's AITS Select series. Okay, so and that should be Because this is an exchange force model and based on Yukawa and all that, there was another video that did not was not watched by many, but I feel this is one of the best videos on the nuclear physics I have produced on a modified Yukawa potential channel. Again, a passage was given, 2 questions were answered. Stable orbit condition, very important one, already asked in the physics Olympiads and can be a candidate for a future JEE Advanced. So this whole video, the link of it is in the description below or I button. You can check it out. Along with that, most of the modern physics questions taken on this channel are unique and slightly the ones where students struggle to find answers on the internet or in their classrooms. So please do make sure you check all the subtopic playlists. I made it subtopic wise. Okay, so Bohr's model 1 playlist, then X-rays 1 playlist. So all those things are in the description below. So please do check it out in case you have not done it yet. Okay, so along with that, a Discord server has a separate modern physics channels where a lot of doubts every day, somewhere around 5 to 10. It's a gold mine for all the questions, and not being part of it, you'd be definitely missing out on something. Also keep checking the community tab of the channel where I'll be posting the questions of the day, QOTD, that are made by the students at the JEE Advanced and Physics Olympiad level. So you can directly join the server. You'll have all the solutions and discussions of those. I think somewhere around 79, 80 are already done by the time of this uploading. So you need to check it out. And for those who are new and don't know what is Discord, I've made a video on how to use the Discord and what is PHYSICSSIRJEE's official Discord service usages. All that video is in the description below or in the I button above. Please do check it out and do join. We'll meet there. Okay, and apart from Resolved series, there are many more parallel series running in this particular channel to help students in their JEE mains and advanced preparations. Not many motivation videos on this channel. Okay, actually zero, because I genuinely believe subject is the one that actually drives you to success. Motivation comes from the proper preparation. So if you are looking for the proper preparation, this is channel for you. Please do check out all these series that are there in the description below and spend some time with the channel. 15 to 20 days, you'll understand the importance of it. Okay. And like I said, I repeat, please do like, share, and subscribe. Liking the video is of utmost importance. And please don't forget it. If you gained something, that is the least you could do and help me out. Okay. So thanks a lot for staying this long, and see you in the next video.